There are many experiments we can do to decide reactivity of metals. For example, displacement or the reaction with acids. If you look at any chart, magnesium is the stronger metal compared to zinc, compared to iron, nickel, copper, and silver. And we can call it strongest reducing agent because it can go through oxidation and make the other metal behave like a non-metal and go through reduction. Let's just look at a case of a zinc and copper. When you take a piece of zinc metal and you place it in a solution of copper, copper solution is usually blue, copper 2+ is blue. After a while, what happens is you will see this color will fade away, sort of, tries to become transparent, and then the zinc gets the plate of copper on it. So the copper sits here. Now this indicates that the reaction is zinc solid with copper 2+, copper sulfate, copper nitrate, aqueous, and it's going to displace it out, and copper comes out as solid and zinc goes into the solution 2+. So here we had Cu2+, and now here in this solution we have Zn2+. Now if you look at the half reaction, zinc is going from solid to aqueous and it's losing 2 electrons, which by definition this was oxidation, and it makes it reducing agent. So zinc is a stronger reducing agent compared to copper, for example. Many times we also include in our chart hydrogen. Although it's a non-metal, but we'll see some metals can displace hydrogen out, and then hydrogen on the other hand can displace other metals out. So let's look at what happens between zinc and hydrogen in a solution. So when you take zinc solid and put it in hydrochloric acid, HCl, there should be a reaction because zinc is a stronger reducing agent. So zinc will displace hydrogen out, will give you zinc chloride, aqueous, and hydrogen comes out as gaseous bubbles, 2. But on the other hand, if for example you take copper and you put it in hydrochloric acid, there is simply no reaction. No reaction. Because copper is not stronger reducing agent than hydrogen and cannot displace it out. So these are examples of experiments we can do, and this is where reactivity comes to life. Now if you look at halogens, then if you go down a group 7 from chlorine, a green gas, bromine, a liquid, red liquid, and iodine, a blackish, purplish solid, this is what happens. Chlorine is now going to behave as an oxidizing agent, strongest oxidizing agent in this group, and it's going to rather gain electrons and go through reduction, meaning it can displace. So if I take chlorine gas, and if we add it to potassium bromide, now what happens is chlorine is much more reactive than bromine, and it's going to displace it. It's a stronger oxidizing agent. On the other side, what you are going to have is bromine, so there will be Br2 liquid or aqueous phase, and it's reddish, and the chlorine, the green gas, goes away and will give you 2 potassium chloride aqueous. And if we do half reactions, then you should agree that Cl2 is going to become 2Cl minus. How does it do that? By gaining 2 electrons, which is example of a reduction, therefore it's oxidizing agent. The same notion goes with bromine displacing iodide. So for example, if I take bromine, a red liquid this time, and if we put it into potassium iodide, then again a transparent liquid, bromine will displace iodide out, and then you will have a 2 kBr potassium bromide, and this time you're going to have precipitate of iodide in form of a solid coming out. This is the case. Now vice versa doesn't work. For example, if I take bromine, let me just this time stick to white color. Just if I put bromine into aqueous solution of potassium chloride, there should be no reaction because bromine is not stronger than chlorine in terms of oxidizing agent or reactivity. So non-metals, we tend to call them oxidant or oxidizing agent, metals reductant, and we can have reactivity series going for them.